right. Hey guys, ready for another session of awesome math? Because I am. We are going to look at some zero product property. We've learned a lot about properties. They tell us what's what and why. In this case, we're going to connect it to some things that we've already been dealing with a lot of. One thing that you guys are really tired of, factoring. You guys all remember factoring, right? We end up taking something like x squared plus, I don't know, x minus 4. And we end up breaking it apart, factoring it out, and seeing how we can expand it into two quantities being multiplied together. Well, our purpose today is to connect that idea to another relationship. Once you know what I am drawing, let me know. Just popcorn out the answer. Good. That is connected to what I'm doing. Coordinate plane, graph. Those are all keen observations. You all smarty pants. You got it. A parabola. A parabola is a graph of what kind of function? Quadratic. Oh, that makes me so happy that you guys know that. I love you guys. Okay, so here we have a quadratic function being graphed as a parabola. So this one is opening upward, so it's a happy one, it's positive. We have a couple key points that they help me draw the graph. Does anyone know the special names for these key points here? Yeah, there are a bunch of them. Zeros, roots. Good. I heard solutions. Nice. And I heard one more. What was it again? X-intercepts. Nicely done. Intercepts. Yeah. Okay. How many zeros or roots or functions, solutions, or x-intercepts do we have in this case? 2. Exactly right. If my parabola went floating off into La La Land, how many solutions would I have then? Nada. 0. Good. It does not touch the x-axis there at all. This one is firmly rooted, though. Twice, in fact. We could even just have one root, right? If it's just sitting here, perching right there, it would have just one x-intercept. All right, good review. Thank you much. Class is over. No, wait, there's more. There's more! We're just getting started. Okay, so I want you guys to think about something for a minute. Consider this. If we know, this is really hard now, so brace yourselves. A times B equals 0, then what can we determine about the value of A and B? Don't say it, just think about it for a minute.
I do the same thing. Don't say it.
Okay, if you're done thinking, you can turn and talk to someone next to you and tell them what it is. Each of you turn and talk to someone. All right, Chris, what did your partner or you decide?
My partner said that at least one of them must be.
Okay, so Chris said that his partner said, so this is a rumor now, but we'll go with it. At least one of them, A or B, at least A or B must also equal 0. Okay, you guys got it. This right here, that pretty much summarizes what the zero product property is. Now we just have to apply it. So this is the zero product property, but let's write it like all formal like and beautiful. Okay, so in your notes, I want you guys to document this and keep it forever and ever. Okay, except for on days that don't end in Y, then you can throw it away. So we have the zero product
That doesn't make any sense.
Just do what I say if you want to pass. Okay? Write this down. If A times B equals 0, then, that's a comma by the way right here. That's nice. Then at least A or B must equal 0. Okay, so now this could just be, with single variables here, A and B, but that's a little bit boring. We can look at it now with our knowledge of factoring and quantities, mix it up a little bit. So let's say that A could be represented by the quantity x plus 5, and our B is really x plus 7, right? So what does that tell us about each of these parts? What does that tell us about x plus 5 and about x plus 7? Okay, work it out on your paper. It's ready to tell me. Quiet think time. Okay, so go ahead and share with me what you're thinking about the first one, x plus 5. What did we come to decide about x plus 5? It might equal 0. Okay, so let's just look at that possibility. And then we'll also say, hey, on the other hand, what about x plus 7? Don't leave him out. He also could equal 0. We could have the parentheses or leave them out at this point. It's pointless to consider it. All right. In the first case, if we solve this, what would we have to do? How do we get rid of the 5? Subtract 5. Okay. So minus 5, minus 5, easy peasy, x equals negative 5. But that's just one condition. So another condition, or we have to look over here and solve the same way. Minus 7, that's the canceling it out there. X could also equal negative 7. And so we can determine from using the zero product property that our solutions could be negative 5 or negative 7. And a fancy way of writing that we've come to this conclusion is we could say, oh, therefore, our solution is blah, 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 blah. I like to use the therefore symbol because if you show it to like your little brothers and sisters, they're like, what are you doing? Your math looks so hard. And I just like it because I'm a lazy mathematician. So it really just means therefore. And I use a lot of that shorthand stuff. Okay. And if we had a graph that kind of went along with this case, what do we now know about it? What does this tell us? Connecting it back to what we're talking about. We know our x-intercepts. Good. So one of them, negative 5. 1, 2, 3, 4, 5. Put a dot. 6, 7. Put a dot. Okay. So we know our x-intercepts. And we'll be discussing this more later, but that is all for now. Thank you.